Okay, so in this video, I'm going to show you how to implement a stack using linked lists in Python. Alright, so the last time I showed you how to implement a stack using arrays, but this time we're going to show you how to operate a stack using a linked list. Alright, so yeah, we already have a video on implementing a stack using arrays, so make sure that you watch that first before watching this video, because it's going to help you give you a rough idea. Right, so yeah. All right, so before I start and move into the code, I want to show you this time how we're going to operate a stack using a linked list. All right, so if you let's say, for example, you have an empty stack, right? So what would an empty stack look like this, right? There's no element. So an empty stack would basically look like a white page of paper, right? There's no element. And if you're using a linked list, there's no node, to be more specific, right? So let's say, for example, you want to push, I'm sorry for my handwriting, I'm using a mouse, right? So let's say you want to push 3. Okay, so what's going to happen is this. We're going to see 3 being pushed into the stack, right? In linked list terms, if you say push 3, then something like this happens, right? If your stack is empty, what you do is first create a node. All right, and you already know by now that a node has 2 specific parameters. One is a value and another is a reference. Okay, so if you say push 3, and we're going to first create a node with the value of 3. And since it's the first node, we don't need any reference value, right? Because who is it going to refer to? All right, so now let's push something else. Let's push 4. So as a normal stack representation, we're going to have 4 over 3, right? Since it's a LIFO data structure, so the last in comes out first, so 4 would be over 3. Okay, so how is it going to look in terms of a linked list? So if we say that we want to push 4, then we'll create another node and we'll have 4 in its element section, right, or in its value section, and we're still to figure out what would be the reference value. Okay, so all right, I skipped something, sorry for that, right? So just go back a step. So for the first time when you're creating a node, let this be your head. All right, okay, so now that you've created another node, while you create a node, you do something like this, right? N equals to new node, and then you push the value, right? So this is temporarily accessed by something called n, right? And this is accessed by something called head. So what I'm going to do is I'm going to say n dot reference equals to head. So it's going to create a link to this node, right? And then I'm going to say that head equals to n. So what this does is it moves the head from this position to this position, right? So I know this is a bit odd because we're used to seeing linked lists moving to the right, but we're moving to the left. And why are we doing this? It's because of a very special purpose. All right, you'll figure this out when I will show you pop. All right, the pop function, you'll figure this out why I'm moving this to the left. That's it. So when we can understand that the head points to the top of the stack, right? So if I say that peak, then I'm supposed to get 4 because 4 is the top of the stack. So the peak function is going to show what? Head dot element or head dot value, right? Then we're going to get 4 because it's at the top of the stack, right? Similarly, if you want to push another element, let's push 5 this time. So we will have 5 over 4 and 3, right? So what are we going to do? We're going to create another node. So let's say n equals to node and 5. So let's let this be 5. So we're going to have another node called 5, and we're going to do what? N dot reference equals to head, right? So what is it going to do? It's going to link this one to the linked list, right? And then we're going to say head equals to n. So the head moves from here to here, right? So now if you say pick, and pick does what? It shows the value of the head, the value of the head. So it's going to show us 5, right? So it's going to show us the topmost value. All right. So I guess you got the idea, right? If you guys are still facing confusion, so don't rewind the video, watch this back over and over again. Okay, so this is the main ideology, the main idea that we're going to follow. So we're going to create nodes, and we're going to attach to the left. We're not going right, we're going left, right? Okay. Right. So now I want to finish up with this explanation first, right? Why did I choose to go left? If you guys have already covered this in your theory, then you're already good to go, right? You don't have to watch this part because this is a theoretical matter. But if you still have confusion, I'm not sure, so that's why I'm creating this part. But this is how I'd like to solve the problem. So yeah, you can get your main idea from here, right? So let's say you have 3, 4, and 5, and this goes on and on and on, right? Okay. So this is your head. So the stack implementation, how in terms of stack, it's going to look like this, right? 3, 4, 5, right? Not the other way around. It's going to be 3. It's going to be 5 over 4 over 3. Okay. So there's a special function. It's not a special function, sorry. There's this function called pop, right? So what pop does is it returns you the topmost value in the stack and removes it from the stack, right? So if you say 5, if you say pop, then you're going to get 5 in return, and the 5 would be removed from the top, right? So the top of the pointer is going to point to 4, right? And if you say pop again, then this 4 would be removed and returned, and the top of the pointer would point to 3, right? So in linked list terms, how am I supposed to implement this, right? It becomes very easy if we notice that it becomes very easy if you follow this left hand side rule, right? So if we say that pop, then we already know that this is the topmost value, so we can return head dot value, right? And make a temporary node, let's say n or no, all right, let's say temporary node, so temp equals to head. So temp is going to point over here, and then we can say head equals to head dot reference. So this is reference, this is reference, this is reference. So head equals to head dot reference. So head is going to move from here to here, right? So you see, you've already done half of the job. You have moved the pointer from here to here. Now what you have to do is remove this item from the stack. So if you want to remove, you can refer to this. You can access this node by, you already know there's something called temp. So you can access this node using temp. So you can put temp dot value to be none, and temp dot ref to be none. So if we run this much of code, then what is it going to do? It's going to remove this node from the linked list. So we are left with this part of the linked list, which is exactly what a pop function is supposed to do, right? If you put again pop, then it's going to remove this, and it's going to move head towards the next node, right? And this is going to happen so on and so forth, right? So I guess you got the main 3 functions that we're supposed to deal with, right? And this is exactly what I'm going to code, right? Okay, so let's get started with the coding part. Again, if you still have problems understanding, rewind this video. This is pretty easy to understand, right? So rewind this video, watch it over and over again, all right? and then try to solve. This is, if you watch this over and over again, you should be able to understand this. All right. Yeah. Okay. So let's start off with the code. So in order to have a linked list, we need to first have a node, right? So let's write a class called node. All right. And what does this node do? It basically creates the node. So it has a constructor, and when you create an object of this node, then it will run the constructor, and we can pass a value inside the constructor to save that as the value of the node. Okay. I'm really sorry because I'm talking very slowly. I mean, it's a very slow pace because I'm typing and talking, so it becomes difficult. Okay, so yeah. So we created a class called node, and we have a constructor, and when we create an object of node, then what are we supposed to do? For example, let's say this is how we're going to create a node, right? So node, and if you pass a value called as 4, then it will create a node with the value of 4. All right. Okay. Now we're going to implement a stack, right? So let's create a class called stack, and this stack is going to in turn make use of nodes. All right. So you must have a head. So let's say you have a head, and let that head be temporarily none. Okay. So we're going to do what? We're going to have those 3 basic operations, just like the implementation of stack using arrays. We're going to implement the same functions. So let's start off with push. All right. So let's say define push and to self and data. Okay. So the push method is taking data as a parameter. Okay. And we're going to see whether if it is the first element that we're creating. So if it's the first element that we're creating, then the head is supposed to be empty, right? If it's not the first element, then head is supposed to have some value. Right? I'm repeating. If it's the first element that we're creating, then head is supposed to be empty. Head is not going to point anywhere because there is no element inside the stack, right? There is no pointer. Take a sip. Similarly, if it's not the first element, then head is going to point to something. So head's value is not going to be empty. So how are we supposed to know that if it's the first element or not? We're going to see whether self.head equals to none. If it is, if it is none, it means that it is empty. Okay. So if it is empty, then what are we supposed to do? We're going to create a head, self.head equals to, we're going to do what? Node, create a node of that value. So it means that we want to push a certain data. Let's say we want to push 2, and let's say data contains 2. So if we say that self.head equals to node.2, then a node is being created with 2 in its value, and head is going to point there. All right. However, if it is not the first element, I mean it's not an empty stack, then let's say we'll create a random node by referring it to as n, and we're going to pass in the data. Okay, we're going to say n.ref equals to self.head. Remember, pointing to the right. So we're creating the node to the left and then making it point to the head, so it becomes, we're going leftwards, right? And then we say that self.head equals to n, right? So the heads move to the left, right? Sorry, the head moves to the left. Okay, so yeah, that's more or less, I think that's it about push. Okay, so let's say we want to finish off with peak. So we're not going to take any value when we're peaking. We're just going to access self, the global head, right? So peak. So if you're going to peak, then what are you supposed to do? You're just supposed to return the topmost value, that is the head's value. So return self dot head dot value. Okay. Again, I didn't do something over here because I assume that this is not an empty list, right? So you need to create a check for yourself whether the list is empty or not. Yes, it's just a regular guideline, right? That's why I didn't check that extra part. But while you're coding, make sure you do that. You check whether it's an empty stack or not. If it's an empty stack, then you don't really have a head dot value, so it's going to return you an error, right? So yeah, you need to handle it. Whether if it's an empty stack, then code accordingly. If it's not an empty stack, then you return this value. Okay, so that's it about pick. Let's move on to pop. All right, so still we're in pop. We don't need any so in pop we don't need to pass any parameters, right? So we're not taking any parameters, it's just self, because we want to access this global head. Okay, so before we popped, we have looked into this logic. We assign a temporary node, right? So temp is equals to self dot head, and then we say self dot head equals to self dot ref, and then we say temp dot value equals to none, because we want to remove this garbage value, and then temp dot ref equals to none because we want to remove that link. So the entire element from the stack gets removed. So this part basically moves the pointer to the next element, and this part basically removes the element from the stack, right? So yeah, that is more or less, I guess, that's it about stack, the basic implementation of stack. Again in pop, you're supposed to check whether the stack is already empty or not. If it's empty, you say that you can't really pop anything. However, if it's not empty, then you use this piece of code, right? And how do you check whether it's empty or not? You just simply see whether head is equals to none or not, right? Just what you did over here. Okay, so let's see whether it runs. So let's create a stack. So we have created an object of stack, and let's say we want to push 1 into it. So 1 is pushed inside the stack. So if you want to pick, it's going to return us 1. So we can print that value, right? So let's say it does, yes, see, it returns us 1. Okay, so let's run this part again. Let's push another value, and let this be 2 this time. So if we say peak, see, we pushed 1, we peaked, so 1 was initially there in the stack. So if we peaked, we would have seen 1, so we got 1. Then we push 2, and then if we again pick, then what does peak do? Peak shows the topmost element. So 2 is above 1, 2 is on top of 1, right? So if you want to peak, we'll see 2, so it prints 2. Alright, so push and peak are working perfectly. So let's see whether pop works fine or not. Right. Stack dot peak. So if we say pop, what's the current state of the stack? We have 1, and then we have 2 over it, right? So if you say pop, then 2 is supposed to be removed, and then if you say peak, right? If you call peak, then we're supposed to see what? 2 is already removed, right? So we're supposed to see 1. So let's see. Where is it? Self.head. Oh, sorry. Self.head equals self.head, right? Yeah. So yeah. So if we say pop, then where are we going? What are we seeing? We're seeing that the 2 that we inserted last gets removed. So we're left with 1 only, right? So if you peek, then we're going to get 1. So yeah, push, peek, and pop, all of them are working fine, and that is it about implementing a stack using a linked list in Python. All right. If you have questions, try to rewatch this video over and over again. All right. It's explained in detail. All right. So you don't have to. I mean, it's fine if you have questions, but yeah, watch this video as many times as you can. So it's very detailed. All right. And then if you still have questions, then please feel free to ask us. All right. So yeah, thank you for watching.